just like with proving triangles are congruent, there are ways that you can prove triangles are similar. So the three ways are angle, angle, side, angle, side, and then side, side, side. The first way, angle, angle, is if you know that two angles are congruent, then the triangles are similar. So down here, these two angles are congruent by the vertical angles theorem. So I can write a triangle similarity statement. So before we had triangle congruent statements, now it's triangle similarity. So you have to match them up. So R matches up with V. S matches up with S. W and B match up. So this is B. Here's another example. MX is perpendicular to AB. So we know perpendiculars make right angles. So we have two angles. This one has a 58, this one has a 90. This one has a 58, this one has a 90. So to write my triangle similarity statement, I take one of the triangles, AXM, similar to triangle A matches up with B. X is a 90-degree angle in both of them. And then instead of writing M, I write K. So those two triangles are similar because they have two angles that are congruent. The second way is side, angle, side. So the angle in between the two sides are proportional. So X is to A as Y is to B. So down here, I know that these two are vertical angles. So the way I do it is I take one of the triangles and I write the triangles from least to greatest. So the sides from least to greatest. So 12 and 18. Then I take the other triangle and I write the other triangle from least to greatest. So 24 to 36. And now these two triangles are similar if these sides are proportional. So if these ratios are equal. So you can either check by doing the cross product, seeing if the cross products are equal, or you can reduce this. So 1/2 is equal to 1/2. Yup. These are similar because of side, angle, side. The angle is between the two sides that are in proportion to the triangles. Now let's try, I need to write a similarity statement. So Y, V, Z is similar to triangle. So Y matches up with W, because that's where the short side is too. V is V, and then this has to be X. And then the last one, put the angle markings in. We're going to see if it's side, angle, side. So I take one of the triangles and I write the sides from least to greatest. Then I take the other triangle and write those sides from least to greatest. And I want to see if those are equal. Are the cross products equal? So does 50 equal 48? Nope, they're not. Or you can see this reduces to 3/5, which is not the same thing as 5/8. So nope, these are not similar. And then the last one is side, side, side. So checking to see if all of the sides are in proportion. So I do the same thing. I take one of the triangles and I write the sides out from least to greatest. So 6, 6, 9. Then I do the same thing with the other one, 8, 8, 12. And I need to see if all these ratios are the same. Well, this is 3/4, this is 3/4, and this is 3/4. So yes, triangle A, B, C is similar to triangle. Now, since this is an isosceles triangle, they can kind of match up. So A can go with either E or F, it doesn't matter. So E, and then F, and then G. So down here, I'm going to write them out from least to greatest on the blue triangles. So 6, 8, 10. Then I do least to greatest on this triangle. 3, 4, 5. and I see if all the ratios are the same. Well, this is 2, this is 2, this is 2. So yes, the triangles are similar. And there's no letters on here, so I'm not going to do a similarity statement. Indirect measurement is calculating without measuring something. So you use this when we're doing we use similar figures, similar triangles, we use trigonometry to use indirect measurement. So there's examples on the next page. So first, let's go back to, are these triangles similar? If so, write a similarity statement and name the postulate theorem you use. So you'd use either angle, angle, side, angle, side, or side, side, side. So first I like to mark in these vertical angles right here. So if I have these, is this going to be a situation of side, side, side? So is it side, side, side? No, because I don't have 3 sides. I only have 2 sides on each triangle. Is it angle, angle? No, because I only have 1 set of angles that are congruent. Is it side, angle, side? No, because the angle is not in between the 2 sides. So no, these triangles are not similar. And then next one, I have 2 parallel lines, and these are my transversals. So these angles are congruent, and these angles are congruent by alternate interior angles. And these angles are congruent by vertical angles. So this is going to be an angle, angle. So the similarity statement is the triangles are similar. So now you have to match them up. So triangle WRT is similar to, so W matches up with X, R matches up with R, and then I guess there's 2 W's right here. W again. And down here, solve for X in each. So you're going to use, I have angle, angle right here. Angle, 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 angle. So these 2 triangles are similar. So their sides are in proportion. So 6 is to 3 as X is to 2. So you use cross products. 12 equals 3x. X equals 4 is your answer. And then these 2 triangles over here are similar by angle, angle again. So 6 is to 8 as, now 6 is between the 1 and the 2 marks. X is between the 1 and the 2 marks. So I have to put X on the top. X is to 12. So this is going to be 72, because that's 72, equals 8x, x equals 9 is your answer. And then down here, when a 6-foot man, so this guy's 6 foot, cast a shadow that's 18 feet long, a nearby tree, so a tree, cast a shadow that's 93 feet long. Since the earth is coming, or the sun's coming to the earth at the same angle, these are similar triangles. So this angle is going to match up with this angle. So these are similar triangles. We're trying to figure out how tall the tree is. So we're going to use a proportion. 6 is to 18 as x is to 93. So x is equal to 6 times 93 divided by 18. So it's going to be 31 feet. So I did 6 times 93. 6 times 93 equals 18 times x. So I divide both sides by 18. So the height of the tree is 31 feet. And then down here, in the sunlight, a cactus, horrible cactus, cast a 9-foot shadow. A 6-foot person, worst person, that 6 foot tall cast a 4 foot shadow. How tall is the cactus? So again, you have the same angle markings. So this is going to be x, so you can do x is to 9 as 6 is to 4. So this is indirect measurement right now. I'm not actually measuring the height of the cactus, but I'm using similar triangles. So it's going to be 4x equals 54. Divide both sides by 4. X equals 54 divided by 4, which is 13.5 feet.